Hi everybody, it's your boy Sekumar. It's been a while. I don't come out with new video, so today I'm here with a good video and project, which is Fun and Wings PID control projects. So to begin with, let me give you a clear idea what I'm going to tell you about this project. It's actually a basic project, but if you are able to understand this one, you can do any kind of real life projects. For example, you can control an airplane wings or maybe wind turbines. You can understand the mechanism behind it. So let's begin with it. I will tell you what is the purpose of it. Generally, it's widely used in these sections, and let's go on. Yes, the purpose of this project, in this arrangement, we try to keep the wings angle um, at a stable mode by controlling the speed of the fan according to the angle value desired to be entered in the system. We try to you give an input value in the reference, and the system try to keep that angle, the angle in that value. So I will show you the picture, you will understand. Before we go, let's show you the list of the material that we need to have in order to do this project. This is the mini drones. We need two motors, mini drones, and motor propellers as well, clockwise direction and anti-clockwise directions, which cost these values. At the moment I'm making this video. And we need a LCD screen for a display in order to see what are our KP value, KD value, and KI values, so we can see when we manually manipulate our controller. We need a microcontroller, Arduino. I choose it for the purpose of this video, but if you like, you can use another type of microcontroller like STM32 or Texas Instruments or any other type that's make you comfortable to program. MPU 6050 or gyro sensors is also useful. It's collect the feedback data, like the angle. It measure the angle and send it to the reference, like in the comparator, and it's compare the value. So we need 10 K potentiometer, 5 or 6 of these ones, or 7 maybe. So I take 5 because I already have an extra. You can buy 6. 3 will be PID terms, and the 3 other will be, one will be the reference, another one will be controller, one will be the wings handles. I will show you the picture so you can understand. And we need a Sigma profile 6 channel, or if you have any wood, you can use that one as well. We need a channel. We need a 6 channel connectors as well. We need female jumpers, female male, and male jumpers. I'll put the links down below the description side. Let's go for the working principle. Yes, like I say, it will be used the Arduino microcontroller. However, microcontroller integrate programming is done by the PID algorithm, and PWM signal is sent with the PID algorithm according to the reference input that I said before, enter to the motor driver, which amplify the signal and give it to the motor in terms of PU's algorithm. It's applied DC voltage between 0 to 5 volt range and must be winged by the air supply with the motors. The idea behind this one is to control the system with PID so that it can handle the bar in a specific angle given. Since we will be focused on the control side of this project, because I want to make the simulation of this project. Of course, I will tell you also more about other sides, but I'll focus more on the control side. So, like I will not show you much more about the coding side and wiring and welding and power supplies, but that will come in practice, as this is the simulation yet. So let's go with the project descriptions. What is controller PID? To follow this project, you should understand these terms. What is PID in terms of control system, what is plant, and what are sensors as well. So let's have an idea about this. A PID is nothing else than proportional, which is stand for P, sometimes KP as well, and integral, I for KI as well, and derivative terms for D or KD controllers. These three terms controller are widely used in closed loop mechanism in feedback systems, and a lot of industrial companies use it as well. It's quite easy to control anything with PID controllers rather than many other controller stuff, so that's why it's widely used. Like I mentioned before, these are the potentiometers. This is the potentiometer you can see. This is the KP, KI, KD, and controller reference. Then the other one I was talking to you, I will show you in the next coming video slide. Let's go. What is plant? Plant is nothing else like the combination of the process and the actuator. In other hand, it's also like the component whose variable is being controlled. Like here you can see this red one is our drivers and motor stuff there, that are our plant model here, as you see here. Let's go and what is sensor? The sensor is a device that detects and responds some type of physical input, some type of input from physical environment. You can see from here. For example, it could be any sensor like heat sensor or airspeed sensor. When you think about a drone, for example, they use airspeed sensor sometimes to detect the airspeed. And here we are going to use a gyro sensor, which will detect our angle here from physical environment, like the bars oscillation, and send it as feedback to the comparator. Let's go. This is the block diagram. The block diagram algorithm. Before we start with the simulation, we should have an idea about the block diagrams algorithm. So we give a reference input, and that reference input is checked by the comparator, and after give to the controller which for example, you know the microcontroller Arduino use a voltage range of 0.5 volts, and that give a PWM signal to the driver. Then driver will amplify it and give it to the motors. Then after it will come to the wings mechanism system. For example, the disturbance here, it could be, think like the wing of our project here. Somebody touch it and push it down, or maybe push it up to change the position of the angle. So the motors as an actuator try to keep it in a stabilized mode, to keep it as according to the reference input. So if there is any disturbance, it check it, the sensor check it and try to measure again and send the feedback to the comparator in the reference side. Then the same scenario keep going on the same way. Okay, this is the wiring diagram. Here you can see electronic side, and these are the potentiometers, and this side is considered like the Arduino, and the green one LCD screen, and motors, red one motor driver. These are like our, this side is is considered as control side. This display, LCD display, enable us to see what are the KP value, what are the KI value and KD value according to the manual changing of our system. For example, we'll try to change our values to have a good performance of the system. So this display is important. And this here microcontroller give signal to the driver, and driver give the signal to the motor. As you can see here, the signal come here, and motor start spinning in one in clockwise direction and one in anti-clockwise directions, and this angle is measured by the gyro sensor that give it back again to the controllers. Then the same system keep going on like that. Yes, thank you. This is done for this one. I will continue in the next video, so let's break it up here. Thank you for coming and enjoy. I hope you enjoyed the video. It was informative.